Hello, Algebra 1. Today we're going to look at a couple more examples of explicit and recursive patterns and building the formulas in both ways to express a pattern. And this should be a nice warm-up for your first quiz or just some great further examples. So you've got two patterns here. You can see that one of them I've expressed in a table. Get my cursor going. Hold on. Thank you. My handwriting might be a little sloppy because I've injured my finger, so I'll do my best. Anyway, we've got two problems, and the first one I've expressed as a table. We've done quite a few of those now. The second one I've expressed just with the bald sequence notation, which is more like what we'll be working with as we move forward, and like problems you'll see in the future. So let's have a look. So you might want to pause the video now and try these both as a warm-up, or maybe just try the first one. That's what I did with my class. Anyway, so we want to develop an explicit and recursive formula for each. And you can see for recursive, I've written it with formal and informal. So we're going to write down both the formal and the informal notation. So first, what's going on in this first example? So we're going just one term to the next, up on top, nothing there. What's happening from here to here, and here to here, and here to here, etc. I think after a second you should find, just like the ones that we did yesterday, this has a common difference, in other words, D. So the common difference here is this looks like it's going down 11 each time. So that's what I'm going to write down. And again, excuse my handwriting, my finger is on the fritz. So I think it's going down 11 each time. So that pretty much helps us be able to at least do the recursive. Recursive is pretty easy to do, I think. Explicit's more useful, but also a little bit more challenging, perhaps. Anyway, so recursively, informally, basically, we're going to be thinking like now equals previous. Remember, this is the way that we think recursively. We think about our current step and then back a step. At least that's one of the ways to do it. So if we're now, what do we do with the term before us? I think we take that term and we subtract 11. That's what we do with our common difference. So formally, that notation is a sub n, the current term, is the previous term, which is a sub n minus 1. Remember, you want to say sub, not a n minus 1. It's a subscript n minus 1. Anyway, and we want to take that previous term and subtract 11. So there's the recursive formula. I don't think that's going to be very useful in helping us predict the 45th term up here, because that's really far away from term 6. So we're going to need something a little more powerful to predict that. So explicitly, our formula or our equation is going to be y equals, and we're going to use that negative 11, right? So we'll say negative 11 times the x value. And I don't think it's going to work if we just do that, because if we put in like 1 here, right, then it'd just be negative 11. This number clearly is not negative 11. So I don't think that's going to work. So you remember, you could do this lots of different ways. My class came up with it pretty easily after doing some warm-up. I think the best way is to go back to the 0 term. Remember, go back here to the 0 term. So how do you go this way? That way you're subtracting 11, then this way you need to add 11. So what is that? 47 plus 11? I think that's going to be 58. There we go. I think that's going to work. So now we could go ahead and try that over here. Let's go ahead and plug in 6 and see if we get negative 8. So if we go y equals negative 11 and we plug in 6 and add 58, we could try to do this one by hand or grab our calculator, but I think 11 times 6 is pretty nice. It's negative 66 plus 58, and I think that's going to be negative 8. There it is. I think we're good. Okay, so that was a nice quick check. Let me get it out of our way. So our explicit formula is working like it's supposed to work. Great. So now what I want to do is fill in these last gaps in the table. So now I want to plug in 45. So I'm going to say y equals negative 11. And it really doesn't matter how big of a term they gave me. I can get the value pretty easily by plugging it in to this x. That's the power of an explicit formula or an explicit equation. So this one, that's a pretty big number. So I think I'll go ahead and grab my calculator. So let me pull that up for just a moment. And we'll do it with our calculator. So we need to go negative 11 times 45, and then we'll add 58. Okay, so negative 437. Let's write that down. There we go. Okay, the last problem I wanted to do is kind of an illusion or foreshadowing one of the future chapters we're going to do, and hopefully something you did in pre-algebra, at least some. So this one, we want to figure out what term gave us negative 547. Since we're going down 11 each time, it must be like 8 or 10 away. So I know this is going to be like 50, 60 something. Okay, so let's do this with an equation. So one of our first equations for the year. So this should be nice, bringing you back to pre-algebra. So the y value this time is negative 547. So let me write down the equation one more time. So I'm going to write it down right over here. Just our red explicit equation that we came up with. There it is. And I'm going to plug in for y, I'm going to plug in negative 547, right? That's what we wanted to plug in. So there we go. I'm going to plug that in for y, not for x. We're solving for x, so x is still x. And now I've got to solve this equation for x. Now you guys could guess around to this for a while, but you could also just solve. Remember, that's what we're trying to do with algebra, is eventually solve for things. So if I want x by itself, first I need to move this 58. So to get it to the other side and out of my x's way, I'm going to subtract it on both sides of the equation. So then we'll see what we get. Let me pull up my calculator. So let's do it over here. So we've got, let me clear that, negative 547 minus 58. Okay, so I have negative 605. Put that back, write it down. Okay, so now we have, let me get blue, negative 605. And that's equal to negative 11x. So x is still not quite by itself, so how do I get rid of multiplication? I think I do the opposite. Just like when I needed to do the opposite when I added, I subtracted. So to get rid of multiplication, I'm going to divide by that negative 11 that's in my way. And I think I'll have my answer then. I'm going to be able to say that x in this case is what? So let's pull up our calculator one last time and go negative 605 divided by negative 11. And I think I get 55. That makes sense. Remember, we were thinking that our term should have been like 50, 60 something. So that's it, 55 right there. Solved an equation for x. So that's a good forecast of where we're going to go soon after we work more with these patterns. Let's look at one more before we give it a quit for today and you guys take your quiz. So this time we don't have our sequence, our pattern expressed in a table. We have it expressed just with plain numbers. So first you might want to fool around with this, use your calculator or whatever, and of course pause the video and try to figure out the pattern. So I think this pattern is also pretty simple. We're just going times 5 each time. You know what? I don't like to write my times as x. Surely just write them as dots. We don't want to confuse things as x. This is multiplying by 5 every time. So if we do our informal recursive notation, that would be where we are is going to be obtained by figuring out where we were, or the previous term, and multiplying that by 5. So you know what? I'm just going to put times 5 right there. There we go. So that means that a sub n formally is 5 times a sub n minus 1. There it is. So let's write down the explicit version of this now. So we want to take each thing and multiply by 5. So basically I think that's just going to be y equals, and it's going to be 5 to the x power. Let me do a little bit better x there. There we go. So it's 5 to the x power. We've done one or two of these. This is like the second or third one. It's still something we haven't worked quite as much as with this one. Remember yesterday we introduced the idea for this one. This kind of sequence up here, this one where you're adding or subtracting, is called arithmetic. We still haven't given this kind of multiplying sequence a name yet, so we'll do that in another video, hopefully next time. But anyway, that's the explicit formula. So if someone came and said, well, predict when x equals 8, we could do that and just say y equals 5 to the 8th power. Stick that in our calculator and make a prediction. I think this is going to be a pretty big number. Let's see what we get. 5 to the 8th power. So 5, and use this caret button for raised to the 8th power. And yes, a very big number. That's going to be 390,625. All right, so there's another couple examples. One with an arithmetic sequence, and you know what, I'm just going to give the name of this one away. This kind of sequence is called geometric. So geometric, sometimes also called exponential. So there you go. I hope these were helpful in getting you ready for your quiz or just providing another couple examples in our exploration of basic patterns and sequences. See you next time.